Hi, my name is Jorja Harvey, and my project explores how cultivation and bifenthrin insecticide affects soil macroinvertebrates and soil carbon in sugarcane systems. As climate change places increasing pressure on agriculture, understanding the roles of macroinvertebrates is needed. These organisms naturally improve soil structure, helping it resist drought, erosion, and compaction. They also boost soil fertility and carbon storage by shredding, burying, and mixing crop residues into the soil. So this is relevant because despite many Australian sugarcane farmers leaving crop residues on fields for over 30 years, soil carbon levels have not increased as expected. One possible explanation is that disturbances like insecticide use and cultivation may reduce soil fauna through direct mortality, habitat degradation, or displacement. So I compared two crop stages. I looked at a plant crop, which is less than 6 months since cultivation, and a third ratoon, which is about 3 to 4 years since cultivation. And I looked at some paddocks that received bifenthrin and some that did not. At each site, I measured macroinvertebrate abundance, water level richness and composition, surface pore density, and total and faster cycling, easily accessible labile carbon. So results showed that most macroinvertebrates, including major contributors ants and earthworms, were more abundant in third ratoon paddocks, and that bifenthrin had no effect on earthworms, but treated plots had higher abundances of highly adaptable springtails and big-headed ants. Surface pore density was higher in third ratoon paddocks, and it did not differ in insecticide treatments, loosely mirroring macroinvertebrate trends. Labile carbon was higher in third ratoon paddocks in the top 0 to 5 centimeters of soil, as well as in non-insecticide paddocks at both 0 to 5 and 5 to 25 centimeter depths. Total soil carbon did not differ between treatments. So these findings suggest that time since cultivation strongly influences soil invertebrate communities and their beneficial activities. To support these organisms, future research should focus on practices such as extending the interval between major cultivation events, reducing tillage through less machinery passes, using controlled traffic farming to match row spacings to machinery, trialling dual rows to reduce inter-row traffic, and shifting to zonal tillage that disrupts only the cane row. Future work should prioritise multi-year studies that follow plant to ratoon phases within the same paddocks and track macroinvertebrates, surface pores, and total and labile carbon to account for carbon site-specific nature. These measures should also be linked to sugarcane yield to confirm their influence on productivity and guide management that protects this underappreciated macroinvertebrate workforce. Thank you.